So in this video we are going to be talking about the trigonometry on the Cartesian plane or your coordinate plane. So we typically always have our starting angles and terminal sides and initial side all on the coordinate plane. This allows us to do a lot more math involved, and it also it helps simplify some things. So you are all used to sine being opposite over hypotenuse, cosine being the adjacent over hypotenuse, tangent being opposite over adjacent, and then their reciprocal functions. So now we're going to do it in the terms of these three pieces where we have our x value for this point. So we're going to have some point somewhere on this coordinate plane, and that point has an x and a y value, and it also has a distance from the origin. So we're going to call that distance from the origin to be our radius. So basically here is your point somewhere over here. It has an x and y, and it's going to use the radius for the length of that line. So it's the distance from the origin. So we can then go and change our definitions to use those three things, x, y, and r for radius, to be the sine is simply going to be the y over the r. So it's your y coordinate piece over the radius. And cosine would be the x over the radius, tangent would be y over x. And then the reciprocal functions would be the reciprocal of, well, what they just were. So when we're doing this, we just need to remember a couple important things. We need to remember our quadrants and what is positive and what is negative in respect to those quadrants. So remember, your quadrants start in the upper right hand and go in a counterclockwise circle. And this is probably the first time you are kind of understanding why that is because when we're drawing an angle, we're going in this counterclockwise motion. So we start here in that upper right, then we move on to the upper left, bottom right. So it's going to be important for us to remember our polarity of these signs. So your x and y, so in the first quadrant both are going to be positive. In the second quadrant your x is negative. In the third quadrant both are negative, and in the fourth quadrant your y is negative. So that's going to be extremely important. Those facts right there in front of you on this screen are going to be very important as you move through the rest of this semester, and the reasons why certain things act the way they do. So let's do an example. Let's say that we want to find out what the sine of theta is given the point of -3, 4. So what we're going to do is we're going to just start by sketching where that point is going to be located. So sketching that point, -3, 4 would be somewhere about here. So 1, 2, 3, 1. So there's our point, -3, 4. So we want to find the radius still. So how far is it from that point of origin? So you can see that we've made a right triangle here, where here is my y distance, here is my x distance, and I just need to find my radius. So when we're doing this, we are going to be doing since it's a right triangle, the Pythagorean theorem. So x squared plus y squared equals r squared, and we can solve for r. So one important thing that you need to understand before you start plugging in things here is that the squared is going to take care of any of these negative signs that you have. So there's really no point in actually putting in the negative into your calculator, because more likely you will make a mistake when you do that. So on this one, I'm simply going to do a +3 squared plus a +4 squared equals r squared, and we can solve for r, but this is going to be a 3, 4, 5 triangle, so I already know that r is going to be 5. So now that I know what my r is, I know what my x is, I know what my y is, the sine of theta is just going to be y over r, and for this case it's a positive 4 over a positive 5. So the one thing you will notice about your radius, it's always going to be positive. And the reason behind that is because it is a distance. So because it's a distance from a point, it will always be a positive number for our radius. All right, let's try another one. Let's find the cosecant of theta given the point 20, 10. So again, I'm going to come over here and I'm going to do a quick sketch of where 20, 10 is. So I'm going to say it's about here. So I need to go and I need to find this radius to be able to set up any trig ratio. So we can do that. We can set up the x squared plus y squared equals r squared, because this is your a squared plus b squared equals c squared. I'm just replacing those variables with the variables that are associated with this work. So this is going to be 20 squared plus 10 squared equals r squared. So simplifying the left side, we get 500. Taking the square root of both sides is going to give us, after simplifying it, 10 root 5. Because that is 100 times 5. So the square root of 100 is 10. Square root of 5 is still the square root of 5. So now I know that my r value equals the 10 root 5. So we know what x is, we know what y is, we now know what r is, and we're trying to find cosecant. So cosecant is the reciprocal of sine. So since sine of theta equals our y value over our r, that means that cosecant of theta equals r over y. So we just found out our r is going to be 10 root 5, and we know our y value is 10. So we can simplify that. 10 root 5 over 10 is just going to give us square root of 5. So our answer is just the cosecant of theta given that point is going to be the square root of 5. So how about you guys try this problem and come back and we can talk about it. So on this problem, you should have gotten 4 root 7 over 7. Make sure you rationalize that denominator. All right, so what if we are given an angle instead and I'm trying to find a particular point? So one of the interesting things about this is that if I'm given an angle, there's technically an infinite amount of points that will fall on that terminal side. So what we do is, to make this easier for ourselves, is we simply go and make our radius equal to 1. So we're basically choosing a radius, and then we're going to go and find the x and y point associated with that radius. So we're basically narrowing down the infinite possibilities to a single possibility, and we're trying to make our life easier by simply making the radius 1, because if you remember, the sine of theta is going to be y over r, and the cosine of theta is going to be x over r. So if I make r 1, then this simply is going to say the sine of theta just equals y, and the cosine of theta equals your x value. So if I want to go and find a point, all I have to do is just take the cosine of the angle to give me my x coordinate, and take the sine of that angle to give me my y coordinate. So let's try some. So we have 55 degrees. Okay, we can do that. So again, I'm just trying to find the point. So I'm choosing the radius to be 1. So I'm choosing the radius to be 1. I'm going to do a quick little sketch over here just to kind of check myself to make sure that my answer I found is actually in the correct quadrant. So that's, again, very important for us. So doing a quick sketch, 55 degrees is going to land somewhere over here. So we already said that x equals the cosine of that angle and y is going to equal the sine of that angle. So we're simply going to do the cosine of 55 degrees and the sine of 55 degrees to find our xy coordinate. So we can just plug that into our calculator. Cosine of 55 gives me 0.57, and the sine of 55 degrees gives me 0.82. So does the 0.57 and 0.82, so both of them are positive, so that means I should be in the first quadrant. And if I'm thinking about 55 degrees, that's going to be closer to the 90 than it is to 0. So that means I'm going to have less x distance and more y distance when I'm drawing this line. So that makes sense. So we always want to do these checks because we are going to find issues a lot. There's going to be multiple issues that are going to arise from this. So let's check out the next one. So again, I'm just going to do a quick sketch of where negative 239 would be located. So negative meaning I'm going to go down. So I'm going to be somewhere in this second quadrant. So I know that since I'm in the second quadrant, I should have a negative and a positive answer out when I plug this into my calculator. So let's make sure we get that. So again, this is just going to be the cosine of that negative 239 and the sine of that negative 239 for our x and y. So we can plug that into our calculator. I get a negative 0.52 out, and sine of negative 239 gives me a positive 8.86. So, does our answer that we found make sense? Yeah, I have that negative x and positive y, so that actually worked out. So let's try them with radians. So, when you are working with radians, you need to go and into your calculator find the mode and find the radian button. So you need to switch it from degrees to radians. So all calculators have some mode button, and you are looking for the ability to change it from degrees to radians. So we can do a quick sketch of pi over 5. So pi over 5 will be somewhere in the first quadrant. So that means I should get out positive x and positive y. So let's test that out. So I'm going to do the cosine of pi over 5, and I'm going to do the sine of pi over 5. And I'm simply just going to put it into my calculator just like I see it, making sure I close off this last parentheses at the end of the problem. So, and making sure that I'm in the mode for radians. So we have the cosine of pi over 5 gives me out 0.81, and the sine of pi divided by 5 gives me 0.57. 0.59. So again, both of these are positive, and based off my sketch, I'm in the right quadrant. So the important piece is going to be always checking your mode. If you're working with radians, you need to have that radian setting activated. So at the top of your screen, you should see whether or not you are in degrees or radians at all times. So please, please, please make sure that you are in one of those two things. And before any of you go and take the SAT, just do a reset on your calculator because they work with degrees, and if you're in radians, you're going to get the wrong answers. So just make sure that you reset your calculator back to degree mode before you take any SAT, or just do a reset of your calculator. Just please. All right, so let's look at the next one. So sketching negative 5 pi over 7 is going to give me something in the third quadrant. So I should be looking at a negative negative. So we simply put in the cosine of negative 5 pi over 7 and the sine of that negative 5 pi over 7, making sure we are in radian mode. And I get out negative 0.62, and I get out negative 0.78. So again, I have negative negative as my answer, so I know that I did this correctly. So here are two for you to try. So find the x, y coordinates for these angles. All right, so you should have gotten the point negative 0.93, negative 0.38 for the first one, and negative 0.22 and negative 0.97 for the second one.